When we last left off, our plucky protagonists were magenta, a lurid and unnatural color that I will not allow in my project. So therefore we need to convert our shader to make it compatible with Unity's universal render pipeline. In the previous video, I talked somewhat about my character shader. I had actually made it in Unity's surface shader template, which made it a lot easier to write shaders because it included a lot of the boilerplate stuff that you would need to have. It was also well documented, and the manual had a lot of examples, which you can see right here. Unfortunately, there's no equivalent in the universal rendering pipeline. But they have something better now. It's called Shader Graph. It's a visual graph editor where everything's laid out. It's so easy to use. You just create whatever nodes you want and join them together. You don't have to know the syntax. You don't have to know the names of the different symbols and stuff. Unfortunately, there's no built-in way to create your own custom lighting model, so we can't really use it to convert our shaders easily. That is until recently, and now they do have a whole set of custom lighting examples and nodes that you can use to make your own custom light model. So now is the perfect time to do exactly what I'm trying to do. Before we get into that, here's another reason why I don't want to use Unity's provided shader. So I made a copy of Neville and Maddie here using the standard URP lit shader, and I wanted to illustrate, particularly on Maddie here, see how the lighting here absolutely destroys the illusion of texture. Maddie's hair and hat and clothes, they all look like shiny cardboard with textures printed on. In modern computer graphics, if you want to have any sort of rough texture on something, you need to have a normal map, which provides the shader with geometric information about the shape of the texture so that the light can interact with it realistically. And I could create these if I wanted to, but that would just add a whole lot of extra work to do. So I prefer to do the retro graphics where it doesn't need all of that fancy frills. So let's begin. So firstly, I recorded myself wasting a lot of time downloading the universal rendering pipeline samples, trying to find the sample that had these custom lighting nodes. I didn't read the manual carefully enough. It's not actually in the URP samples, it's actually in the shader graph samples. Whoops. Alright, so I downloaded the samples, and now I'm going through all these shader graph templates to try to find one that I think will work good. So I basically end up choosing the basic lit. And I guess after that I start freaking out because I can't figure out where I could plug in my stuff here. And I start deleting nodes, thinking maybe it would be better if I just started from scratch. So to begin with, I'm going to recreate the same parameters I have on my old shader. So I have a main texture, and then I have a color, which I can multiply times the main texture in case I want to change the color somewhat. And then I also have two scalar values, one that adds to the overall output and one that multiplies. And those effectively allow me to adjust the brightness and contrast in a rough sort of way. And without going into all of the tedious details, what I end up doing is I'm just going to go through my shader code and convert it to the equivalent shader graph nodes. This is one of Unity's lighting examples. I'm just looking to see how they use the light direction. I want to try to find and use the same light direction node in my own shader so that I can incorporate the light direction into my lighting calculation. And here it is, it's the main light. So now we have a reference to the main light in our shader. We'll also bring in a reference to the surface normal, which is a direction vector that indicates the direction that the surface is facing. Now we're going to take our light direction and we're going to take our surface normal, and we're going to plug them both into a dot product node, which will take the dot product of these two direction vectors. When you take the dot product of two normalized direction vectors, the result is going to be equal to the cosine of the angle between those two directions. So we have the cosine of the angle between the light and the surface, and that is directly proportional to the amount which the light lights up the surface. And this is the way that light has been calculated since the very beginning. It's very fast and it's accurate. Of course, over the years, many more lighting effects have been added, but the underlying formulas remain unchanged. So my custom lighting shader starts with the exact same formula, and then I add to it. And once again, I'm skipping over some of the details, but essentially the next step is going to be I'm going to create a custom function node, and I'm just going to copy and paste the formulas from my shader into that node. You can see I just highlight my formula from the shader code and just paste it in here. So this code is just nothing but math, so there's really nothing that needs to be converted here. And then I do the same for this other factor here. I just create another custom function node and paste it in there. And then after this, I skipped over a whole lot of boring trial and error and debugging and all kinds of fooling around, which took a long time and is really boring. But in the end, we got results! So on the outside, you can see this URP lit shader versions of Neville and Maddie, and you can see they're kind of dark because the lighting is a little bit too low for that shader, but it's perfect for my custom shader, which you can see those are the two in the middle are lit by my custom shader, and it looks good. It looks like it does in the built-in renderer, so now we're the same as we were before. Except no, because this shader doesn't handle multiple lights. And in fact, gathering up all the lights in the scene would require a whole lot of tedious code. Thankfully, the Unity Shader Graph Samples project includes a ready-built node that does just what we need. So all that fancy stuff I was talking about with the dot product and all that stuff, we just replace it with this here, and our shader will automatically work with multiple lights. So this actually makes it easier than ever before to create whatever type of shader you want. And in fact, I spent several weeks updating all of my shaders, and then updating all of the materials in the game. And now you can see the results. It looks exactly the same as it did before, which is exactly what we wanted. I've also spent a bunch of time, upgrading other libraries that I've been using. I'm using Unity's new input system and all of that, so now my project is entirely future-proof until Unity decides to change everything once again. Who knows when that'll be.